here is the thrust from the plane pushing on everything inside the plane. Everything inside the plane is in parallel, so everything in the plane is accelerating at the same rate. And then we have this spring and this mass in series. So the spring, force in the spring, which is Fk, and the force in the passenger are the same. So we just have to model those two to figure out what the force in the spring is and what the force in the passenger is. So what's the model for the force in the spring? The model for the force in the spring is here. And that's what we call Hooke's law. Hooke's law. And Hooke's law says that the force in the spring is the spring constant K times the displacement on the spring X. And what's the spring constant is here, given the problem. And then what's the displacement of the spring, which is 1.6 centimeters. So what we have here is 13,300 newtons per meter times 0.016 meters. This I converted the 1.6 centimeters to meters so that the units are the same. And then I'm modeling the force in the passenger using Newton's second law here. So this is Newton's second law. And Newton's second law says that the force is the mass times the acceleration. What's the mass is 65 kilograms, which is given the problem. The acceleration is unknown, so that's what we're going to solve for. Okay? Since we know that the acceleration is the same throughout the entire system. So we can calculate 13,300 times 0.016, and that gives us 212.8. So you have 212.8, and that's the force in the spring. Newtons equals 65 kilograms times the acceleration. And that's what we have here. And so to find the acceleration, we have to divide 212.8, divided by 65, and we divide both sides by 65, and we have the result here, 212.8 divided by 65, and we get the answer is 3.27 meters per second squared. So if I consider my entire system again, the thrust on the plane is accelerating everything on the plane, everything on the plane, everything on the plane, and this spring and the passenger. Everything's accelerating at the same rate. So the acceleration we figured out already was 3.27 meters per second squared. 3.27 meters per second squared. So how are we going to find the force in the plane? The force in the plane we're going to model using Newton's second law again. And that's the mass of the plane, oops, spelled that wrong, times the acceleration of the plane, or everything on board, equals the force of the thrust. Okay, so how are we going to figure out the mass of the plane? The mass of the plane is given in the problem, 175,000 kilograms. So we're going to do 175,000 kilograms times the acceleration, which is 3.27, and we'll find the force of the thrust. So we'll just calculate that really quick. And we get the answers 572,000 newtons. We'll write that to three significant figures. 572,000 newtons. And that's the solution, given that everything on the plane is 175,000 kilograms. And so that includes the passenger and everything else on board. Okay, hope that helps.